Hi guys, my name is Behruz. Welcome back to the Rust blockchain tutorial video series. Today we'll be implementing a very basic version of transaction into our blockchain. Because transactions are a fairly difficult topic, I will be splitting up this topic into multiple different videos. Let's start here by defining a new file transaction.rs. And then inside of this file, we'll define our basic transaction structure. Inside of a blockchain transaction are made up of inputs and outputs. And as you can see here, our transaction has an ID, will be a hash, and then it has an array of inputs and array of outputs. Now, because a blockchain is an open and public database, we don't want to store any kind of sensitive information inside of the blockchain. There are no accounts inside of our transaction, no balances, addresses, coins, or senders and receivers. Instead, everything is done through these inputs and outputs. And then we can derive all these other things from the inputs and outputs. Okay, let's take a quick look for output struct. Output struct is fairly simple. Each output has a value assigned to it, and this is the value in token, which is assigned and logged inside of this output. And then we have what we call the script pub key. Now, the script pub key is a value that is needed to unlock the tokens which are inside of the value field. On the Bitcoin platform, this script pub key is derived through a fairly complicated scripting language called script. But for our first implementation of these transactions, we will not have anything like that. So we'll just use an arbitrary key to represent the user's address. So if the user address is, for instance, John Doe, then pub key will be John Doe, and that will allow the users to unlock the token which are inside of this output. Another important part about this output is that they're invisible. This means that you can't reference a part of an output. For simplicity, if you want to access the value in output, you need to access the pub key. A good metaphor for this is if you walk into a store or shop and you buy $5 worth of goods and you give the cashier a $10 bill, the cashier can't just rip the $10 bill in half and hands you the other half back, and said they have to give you back a $5 bill. So if there are 10 tokens inside of our output, we need to create a new output, one with the 5 tokens inside of it and another one with the 5 tokens inside of the inputs. Okay, let's take a quick look on a text input. Inputs are just reference to previous outputs. We have a 3 fields inside of our input. We have an text ID field which references the transaction that the output is inside of. And then we also need to know the index where this output appears, which is this out field. So if transaction has a 3 output and we only want to reference one of them inside of that transaction, then we say, okay, transaction X at the index 2, and that will be the output that we are referencing with this input. The last field inside of the input is similar to a script pub key in our output. The script sig is a script which provides the data which is used in the output pub key. Of course, because we do not have the script logic in place right now, the signature is just going to be the user account. So like we said before, if you have an account named John Doe, then we are going to push into the signature as well as the pub key. So the John Doe can then unlock the output, which is being referenced by the input in our blockchain. As you can remember, we have our Genesis block. In that block, we also have our first transaction. This is what's called a coinbase transaction. In this transaction, we have only one input and only one output. And the input inside of it, rather than refreshing in all the output, because there are no other outputs, just reference an empty output. It also doesn't store a signature. Instead, it stores a bunch of arbitrary data. The Coinbase also has what's called a substitute or reward attached to it. This reward is released to a single account when that individual mines the Coinbase. In our implementation, we are just going to add a constant for our Coinbases, and we are mainly just doing this to make things simpler. For now, let's build a Coinbase function. So we need to pass into account address and then the data which I want to put into the Coinbase, and both of these are a string, and the output are a pointer to transaction. Okay, if the data variable is empty, then we'll create a new data variable using format macro, which will just say coins2. So we need to pass in the two account address and then the data which we want to put in the Coinbase, and both of these are string. And the output a pointer to a transaction. Okay, the data variable is empty, then we'll create a new data variable using format macro, which will just say coins2, and then we'll put the account name. Then we need to define the transaction input for the Coinbase and the transaction output. For this Coinbase transaction input is reflecting no output, so it has an empty string of for this ID. Then the out index is -1 because again it's reflecting no output, and then the signature is just a data string. In output, we give 100 token as the reward for value, and then the pub key string for this output is referencing to the two address which we are passing here. So when we create a blockchain, if an account named Jack mines this block, then Jack will get 100 tokens. After we implement input and output, we need to hash the transaction and set to the ID. We call a method called setID, which will create a hash ID for this transaction, and then we return a reference for this transaction. The setID method is fairly basic. We use the SHA-256 to create a hash of this transaction and pass to the ID. Before we leave this file, we need to create a few more utility methods which will allow us to determine what type of transaction we have and whether or not we can unlock an output and input. First, let's implement is Coinbase method. We check the Coinbase is value input length is equal to 1, and the transaction ID must be empty, and also the value out must be equal to -1. If all this condition is true, so we determine is the Coinbase. Okay, let's create two methods which we need to unlock the data inside of our output and our input. So for the input, we take a string of the data and pass to it, and we check to see this that is equal to signature that attached to the input struct, and we do the same for input, and we check the pub key equal to unlocking data, and if this came back true, that's mean uh, that person owns the information inside of the TX input or transaction output. So our implementation for transaction right now is complete. We implement a transaction input and output. We just need to pass to the blog and create our first Coinbase transaction based on this file. So for next video, we are going to continue to complete our transaction. I hope you enjoyed this video. Take care.